Hi everyone, my name is Yevgen, and in this video I'm going to show you something that I already started in the first video. Basically, today we are going to talk about an airfoil and external aerodynamics. To be honest, that was quite an easy thing to find something to make an example on. So basically you can see here a txt file which contains coordinates of the curve. So initially I took it from the Excel sheet and then I just converted it to the TXT. Once our workbench is started, so we'll go to Fluent Analysis System. So let's drag it to the project schematic and then we go to the geometry and we want to switch the analysis type on the right side to the 2D case. Otherwise we will not be able actually to transport the mesh to the solver itself. Yeah, it's quite a funny thing. It takes a bit of time to start with the geometry. Anyway, once it will be loaded, we will continue with you importing the curve. So basically that txt file which I just shown in the very beginning. Go to the assembly and then import, open. Let's select the proper way. Let's select the proper extension of the file. This is txt, so all files. Now you can see on your work area just a curve. Actually it was created out of the points, and we want to put this curve into the plane, into that plane which is XY. Again, this is a sort of a restriction from ANSYS Fluent solver. If we do not do this, then we won't be able to prepare a proper mesh, and of course it will not be translated ideally to the solver itself. Now it is in XY plane, but we want to rotate it around this point. So let's just use the move feature and rotate it by -90 degrees. Alright guys, okay, so it's done now. And actually we want now to scale it a bit, because initially the txt file contained an NASA airfoil which was actually built to the Unity. Everything is reference, so that's why the length was initially 1 millimeter, and I want to make it 200 times bigger. That's why I use the pull option and then I use the scale over there. Now you can see that, yeah, it's 200 millimeters, so basically we are done here. So what we want now, we want a bit of external domain, so the fluid, the air, which is going to push, to press on our airfoil. Yeah, you can see here, this is our square, this, not square, sorry, rectangular shape of the domain. Well, it might be absolutely different dimensions. We are not trying to catch the most accurate result here. Anyway, we of course want to get something at least qualitatively nice. So let's move it a bit. Yeah, let's make it center, and the move tool is actually helping here a lot. Okay, so now it's quite a big one. I want to make it a bit smaller. Okay, yeah. And the same dimension from the top and the bottom. Yeah, just nail it. Okay. So more or less our external domain is ready. And what we'll do next, we'll create another body. And I will show you later on, while preparing the mesh, why do we need that second body. It's quite a nice feature, by the way, with the help of this second body, which we'll prepare. You can apply some sizing functions to the mesh, and this is actually very helpful in different cases and scenarios where you want to have a control just on a particular area or volume. Yeah, that is pretty nice thing. Okay, so the initial geometry is almost done. These tiny things we just wanted to add, and that's it. All right. Yeah, let's create that second part. First thing, yeah, I totally forgot. We need to project that curve, which we have imported initially to the surface, and then, yeah, delete that piece, that small piece. After this thing is done, yeah, let's move it to the new component so that we will not be confused later on. And create another one. Let's give it a name of body. Basically, what does it mean? It's a body of influence. And for that, yeah, we'll take the same plane where we will create a rectangular first, and then out of that rectangular you can create, well, whatever shape is on your mind or is required for your particular case. That would be perfect, yeah. It's not only actually allows you to have a very nice control on some particular areas, but it also creates the results in certain areas more precise and accurate. And consumes maybe less computational efforts as well, because you don't need to make the mesh dance all over your domain. Alright, so once your geometry is done, you can just simply close it and go back to the project schematic of the workbench, and in here let's get to the mesh and double click on the mesh. Will transfer us to the meshing tool provided by ANSYS Workbench. Great, now we have it opened, but we still need some time to translate the geometry to the mesher. Yeah, just a couple of seconds more. Unfortunately, my laptop is not the best one. Anyway, hope you guys are using some fancy workstations for your modeling. Okay, so here you can see the geometry which we were working on previously, and here let's go to the mesh and insert the method, because I don't want it to be meshed with quads. Better to use triangles in here. And then you see I go to the advanced properties and change the triangle surface measure to the advanced in front. To be honest, in this particular case it should not actually get any effect on the mesh produced, but in some scenarios you would get better quality, yeah. After that we would need our sizing, and by this sizing I will use body of influence. Yeah, you can set it here, and let's select our body, so that trapezoid which we are going to use as a body of influence. Set the element size, and that's it. In that particular area you have this nice sizing function which will allow you to produce more accurate result with less computational efforts. Another sizing we would require on the surface or on the curves which are representing our airfoil. So let's select that curve, let's go to the sizing and edit, and another thing, the last but not least, obviously, is the inflation layer, which is quite a crucial thing in external aerodynamics. Okay, so we'll set just 4 layers here, and let's generate a mesh and let's see what it's gonna look like. It doesn't take much time. Okay, yeah, you can see it's denser because the mesh size on the curves was selected smaller than the body of influence. It looks okay. Not the perfect mesh, of course, but anyway, this is just a tutorial. I just want to show the approach. It doesn't mean that we're gonna get an extremely nice and proper accurate result. It would be quite close, but anyway, grid independent studies is the thing which one should use if he wants to actually figure out what is the real scenario, what is the real case, and what is the real force acting. So now we are doing the selections. Name selections are things which you are going to use in ANSYS Fluent to apply boundary conditions. So we're going to have the walls, we're going to have inlets, which is the velocity inlet, and we're going to have the pressure outlet. So what the top and the bottom boundary conditions, they are applied with the wall slip. So I will just apply no shear stresses on those walls so that they will not reflect any pressure, and they will not build up any pressure, and there will be no stresses, shear stresses on those surfaces as well. Okay, so here we have just 4 cores. This is the maximum which this laptop is capable of. And let's start the ANSYS Fluent thing. Yep. Once ANSYS Fluent is started, then it's going to take some time to import the mesh which was generated by the mesher from the workbench. And yep, once the mesh is loaded, we can proceed with the models. For that, I think we will not change a lot, but let's see. Let's go to, first of all, yeah, let's change the transient, because we want to capture all those frequencies and all those vertices and vortexes which are generated by an airfoil exerted by the external flow. So okay, let's go to the boundary condition of the velocity inlet, and let's put the value of 10 meters per second. Perfect. And then let's go to the methods and check what is there. Let's leave it by default. No need to change anything here. And let's go to the initialization. And usually for these types of simulation, I use the hybrid initialization. So this is the case right now. We want also to put an autosave. Otherwise, we'll not be able to make an animation in the end. I will show you also how to post-process properly the cases with a transient approach. Alright, so select the proper number of time steps and the time step size. It's obviously the dependence on the mesh size, on the minimum cell. Of course, very good idea to save your case before you start the simulation, because you never know what can go wrong. And if you have a spare saved workbench project, sometimes that's the best thing you ever have. Okay, so let's wait a bit for saving of this project, and let's go back to ANSYS Fluent. And I think we can start the calculation. Okay. So now we start. Yeah, let's see that everything is going smoothly and everything is fine, and then we can, yeah, looks like everything is okay. But unfortunately, I forgot to change some boundary conditions. Remember, I was talking about some wall with slip boundary condition, and yeah, and I didn't apply it right here. Anyway, we'll have to stop this for a bit, and let's go back to that boundary condition, to that name selection of the wall slip. Yeah, exactly, yeah, just right here. I forgot it. Let's check to, yeah, specify shear, and don't put anything, and just continue calculation. This will lead us to a proper one. Just wait a bit. We're gonna do this for a bit and then get the results, and later on I'll show you how to post-process. Okay, so the simulation is done. Yeah, you can see we ran it for a certain period of time. Alright, so let's just close it and let's update or refresh the results. In this way, CFD Post will just try to import the cases from ANSYS Fluent. And this is the proper way of how you can run and start with the post-processing. Sometimes you might run into some difficulties if you just simply double click on the results. That's why I suggest that people click on right button on the results and then refresh it, and only after that double click on that path. And now you can see how the CAD post is appearing on our screen. And there are some details which we're gonna proceed with to be able to get that nice animation which you saw in my previous video in the modeling workflow. So let's create a contour, call it velocity contours, and then we'll go to the symmetry. Oh, sorry, not velocity, to the symmetry. We want to plot the colors of the velocity on that plane. And we want to use the range of the local range. Basically for the 2D case it doesn't make any difference, but just, you know, to make a habit, it's better to start with this. Alright, so let's see what we have. Okay, we have these nice velocity contours, and yeah, but the color of the legend is black, and it's just not really good to catch it. Okay, so now it's a bit better, but if you zoom in again, yeah, black was better. I did it on purpose, and I was not really, it was not really a wise decision. Okay, so let's just make it back to the black one. Okay, and to create an animation, what we should do is to select this nice tab and go to the time step animation. The whole history, which was, oh, you see, the whole history was saved with ANSYS Fluent. Yeah, just a second. This is the result actually of what I did first. A small mistake with the non-applying the boundary condition of the wall slip. That's why you have these contours of the velocity at the first couple of steps. Anyway, yeah. So creating an animation is saving this movie. You can do it like this. You just select the location where you want your MP4 file to be saved, and yeah, give it a name. Let's call it Airfoil Velocity and Profiles, and just simply by clicking this play tab, it will create the contours. It will just duplicate these figures, and it will just, in the end of the day, glue it everything to the MP4 file. Okay, so let's save it to that location where we saved initially all of the files, and let's see what do we have. Oof, nice one. A bit distorted, a bit not in the right position, but this is just due to the resolution, which I didn't select correctly from the first time. So yeah, depending on what you prefer, you can change this image size, you can change the resolution, you can change lots of things, but I guess post-processing is another part, and it's not the part of this tutorial. Okay, thank you very much, guys.